Caldwell to get you? Did you see him? I didn't see him. He's looking. I'm right here.
There he is.
I would have been able to. He can't keep up with me.
All right. I'm on the golf course. I'm on the golf course. There, keep up with it. You guys ready?
You ready?
Camera guy ready? All right. Okay.
Hi. Good morning. My name is Kimberly Kaup, and I am going to start off by introducing my team members of Johnson Construction. We have Mike Zebill, Mitch Reker, Rich Steffen, Landon Lembitz, and Andy Johnson. This project that was given to us is the Sandy River Conduit Relocation, which is located near Portland, Oregon. The Sandy River Pipeline Bridge is considered to be one of the most important projects that would contribute to improving the overall water system. Once this project has reached completion, the system vulnerability of seismic hazards, flood hazards, vandalism, and terrorism will be greatly reduced. The project, or the basis for this project, includes approximately 7,700 square yards of site development, which will include a 450-foot tunnel, 104 lineal feet of a 30-diameter shaft, 208 feet of vertical feet of 9-foot diameter shaft, over 2,000 feet of 72-inch water conduit, and a bridge removal. The overview for this project will include our schedule, problem solutions, construction, site work, project estimate, and our safety. With that, I will turn it over to Mike.
I handled a lot of the scheduling for this project, and some of the big points on the project were actually covered: the 9-foot shaft, 30-foot shaft, tunneling, conduit placement, trenching. So when we put all that into the schedule, we ended up with kind of a critical path of the excavation of the 30-foot shaft, because that led to the tunneling operation, which is the next point. And then the conduit placement within the tunnel was an important point, and then connecting the east trench to the vertical shafts, and connecting the west trench to the vertical shafts. These were all very critical because we had a strict calendar time frame for connecting the conduit and pressurizing with water and placing it into service. The bridge removal wasn't as important because once the water's going, they don't really care as long as we get it done. So for our milestones for this project, there's a lot of complexity of the project, so we put a lot of milestones into it. Our first major milestone was the pouring of the floor of the 30-foot shaft, because that would allow the tunneling operation to begin. We put a milestone at the 50% completion point of the tunnel, and then at 100% completion. Conduit placement within the tunnel, the east trench placement and the west trench placement, and connecting that conduit to the vertical shafts were also major milestones. The pressure testing of the whole system, and then placing number 4 conduit into service, and then placing the number 2 conduit into service. And then the bridge removal basically signify the end of the project, minus the site restoration and punch list. The entire project, we figured approximately 278 calendar days, which is within our 500 calendar day working time frame. That equates to 198 work days. We figure a standard 8-hour day, except for during the tunnel excavation, because we'll be bringing the shotcrete crew to place all the shotcrete, and they'll basically have to work as long as is necessary, just to make sure it's all reinforced so we can continue operations the next day. Some of the big points on this, as I said, conduit number 4 can only be placed into service between the 1st of October and March 31st. And we figured approximately 5 days to get that filled with water and placed into service. The specs called for 3 days, but we wanted to have a couple extra days built into there. And we're starting the 2nd week of February because background checks have to be conducted on everyone. That's an important part, and that can take a lot of time if you're not careful. And so a few extra days of flow have been built into each project because we are in a floodplain, and if there is a lot of rain or something, we don't want to mess ourselves up with that rain. One nice thing with the conduit number 2 is we do encounter a lot of rain in the project. They actually extend the conduit 2 time to place into operation, depending upon rainfall conditions for the area. So if there's been a lot of rain, they don't actually need it in service as early. So that's a nice bullet point for us. Some of the more technical details for the construction, I'll turn it over to Mitch.
I'm going to deal with getting the ball rolling on this project. Obviously, we're going to need to mobilize. We can't do anything before that. And we will bring in the equipment necessary to get started with our site development. And then as time goes on, there isn't a whole lot of room on this job, so we're not going to mold any more than what we need at any given point. The first thing we're going to do is bring in a small clearing crew and get our access and lay down areas squared away. We know that there is a high rain event in this area, so we have purchased some access rocks, so we have something that we can work on. We don't want a quarter-inch of rain shutting down this project overnight. We were going to fence in all our access and lay down areas to make sure all the unwanted people are out. This is kind of a security profile job. They don't want anybody just wandering around out in here. There's the water supply. Once we get our access all set up, we can start moving in our trailers, get our offices set up, and start some of our preliminary laydown. And at the end of all this, when the project's done, then we will restore all our access areas back to the way that they're supposed to be, because that is mentioned in the specs that they do want restoration. So we are going to bring in a seeding crew and get our leveling all squared away at the end of the project. The first thing that we really need to get going to get this job going production-wise is the 30-foot shaft. Everything works off that shaft. So we need to get that started going down the hole. The way that we proposed to do this was to drop in a small 10,000 to 15,000 pound excavator in the hole and start digging out in the circle. Because of the size of it, a drill didn't seem very feasible. So we're going to use the excavator and then a skip box on a crane to lift the material back out. We're going to go down 3 feet at a time to make sure that our shoring is safe. Then we'll put in a band of our shoring while going through the overview, go down another, or the overburden, sorry, go down another 3 feet, put in another band, go down another 3, put in another band, obviously. For the overburden, there's about 13 feet of that, and we figured we could do that at 30 bank cubic yards an hour. It seems really slow, but we don't know what we're going to run into. We're going to have some dead time, you know, stop, start, all that, to get these bands put into place and get everything set. Once we get into the mudstone, we know that that's going to dig harder. We dropped our production to 20 bank cubic yards an hour because we know that is going to slow us down. And then we'll go down another 3 feet, and then we'll start the shotcrete process and put in those steel bands too. Once we get down to the bottom, we're going to pull our excavator out with our crane that's on site, our 250-ton crane, get it out of the hole, pour our floor down there so we have our mud slab to work off of. We're going to put our access ladders in, get our utility lines ran down so they can start with the tunnel. At the same time that the 30-foot shaft is going on, we're going to move over to the other side of the river with our subcontractor, and he's going to shake in his 10-foot casing, get that down, dig it out. We're going to haul the spoils away to the dump site. We're also hauling the spoils away at the 30-foot shaft to a dump site 3 miles away. We're going to haul the same spoils out of the 9-foot shafts to the same dump site. Once he gets that shook down in and dug out, then we drop in our 9-foot casing, weld it all up, and we can pull his 10-foot and start grouting the annulus. He pulls his 10-foot out, we grout it in, and then that is done. Richie is going to deal with getting the tunnel done, and I'm going to hand it over to him and talk about that.